Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 6 from the May-June 2016 International A-Level Cambridge paper. This is the Pure Mathematics 1 and it is the variant 1 from that year. And this question is about quadratics. And one of my students has requested that I answer this question, part A and part B. So I'll start with part A. It says 6. Part A. Find the values of the constant m for which the line y equals mx is a tangent to the curve y equals 2x squared minus 4x plus 8. Okay, so now we will find the values for which this m here in this straight line graph, the gradient of this graph, would be a tangent to this curve. Now the curve y equals 2x squared minus 4x plus 8 would be a quadratic type of curve looking like this. And the line y equals mx would be a straight line. It could have a positive gradient, it could have a negative gradient, okay? And we want to find the values of m such that this line will be a tangent to the curve. Now, tangent to a curve is when the line, the tangent, just touches the curve in one place without cutting through it, okay? It touches the curve in one place without actually cutting through the curve. So it doesn't do this. It doesn't miss it completely, but it just brushes past it at one point. At that point, the line is a tangent to the curve. So we got to find the values of the constant m for which this would be a tangent to the curve. Now, or a curve and a line can either never intersect, or they can intersect in two places. It's a quadratic curve and a line, or they could intersect in one place, okay, where that's the case when the tangent is or the line is a tangent to the curve, right? So those are the possible situations you can have. So if I want to find where this line and this curve intersect, I have to solve the two equations simultaneously. So y equals mx and y equals 2x squared minus 4x plus 8. I have to solve these two equations simultaneously. So to solve equations simultaneously, what you basically do is you substitute inside one equation what the other equation is. So instead of the y here, instead of this y, I can write 2x squared minus 4x plus 8 because y is equal to that. All right, so that's a substitution here will help us to have an equation with just x and no y's in it. So I'll write 2x squared minus 4x plus 8 equals mx. So this looks like it can end up as a quadratic equation, which the solutions of which will be telling us about the intersection between the line and the curve. The solutions to this equation will tell us about the intersection between the line and this curve. Okay, that's what happens when you solve equations simultaneously. You basically find out about the intersection. Okay, now to make this in the form of a quadratic equation which we can solve, ax squared plus bx plus c equals 0, I'm going to subtract mx from both sides. So I have 2x squared minus 4x and minus mx and plus 8 equals 0. So what I'm going to do here is I'm going to take out the minus, okay, x from both of these terms. So I have minus x and I have 4 plus m, okay, plus 8 equals 0. So I have minus 4x and minus mx. This is exactly the same as that, just factorize. And what I'm going to do to make it even easier for me to do with, I'm going to write I'll write it as 2x squared minus, I'll have in brackets 4 plus m times x plus 8 equals 0. So the solutions to this equation will tell us about the x coordinates of where these two intersect. Now I want to find the value of m, such that the intersection between these two will only be in one place. And as this is in the form of a quadratic, we can use what is called the discriminant. Now the discriminant, which is given this triangle symbol, is basically b squared minus 4ac. Now why is it b squared minus 4ac? Because the quadratic formula that will help us find the solutions to this is minus b plus or minus the square root of b squared minus 4ac all over 2a. That is the quadratic formula. and the part of the quadratic formula underneath the square root sign is called the discriminant, because it discriminates between the number of solutions that a quadratic equation has. If b squared minus 4ac is 0, then you'll have one solution minus b over 2a, which is what we're looking for, just one answer, one place where they intersect. If, however, b squared minus 4ac is positive, you'll have two solutions, because you'll have minus b plus something over 2a and minus b minus that same thing over 2a, so you'll have two different solutions. And if b squared minus 4ac is negative, then you'll have no solution, because that will give you no real answer. It'll say math error, you won't find a real answer for that. So that will be the case where they don't meet. So if they don't meet, okay, you'll put b squared minus 4ac is less than 0. If they intersect in two distinct places, then b squared minus 4ac will be greater than 0. If, however, you want to find where the line is a tangent to the curve, that means they meet at one place, then b squared minus 4ac will be equal to 0. So we have to set b squared. What's happened here? 1 second. Oh, it's doing the highlighting. I forget that my normal pen. So we have to find the case where b squared minus 4ac is equal to 0. So in this case, we have the values of a, b, and c. A is the coefficient of x squared, which is 2. B is the coefficient of x, which is minus 4 plus m, in brackets, all this, don't forget the sign, and c is equal to 8. So we're going to use b squared minus 4ac, we're going to make it equal to 0, and that will help us find the value or values of m. So I'm going to square 4 plus m minus 4 plus m. So if I square minus 4 plus m, if I square that, okay, minus 4 times a, which is 2, times c, which is 8, that has to equal 0 for us to have a tangent. So if you square this, the minus is going to become a plus. You're going to have 16. And in fact, I'll leave it like this, 4 plus m squared. That will be easier for us to solve, actually. So I'll leave it as 4 plus m all squared. The minus sign, when you square this, is going to become positive. I've left this as 4 plus m all squared, and you'll see why in a minute. That's minus 4 times 2, that's minus 8. Minus 8 times 8 is minus 64, equals 0. So what I can do here is I can say 4 plus m squared is equal to 64. Now to solve this, I can square root both sides. So I'm left with 4 plus m equals 8. Okay, you can say plus or minus 8. And in fact, you should say plus or minus 8. Okay, because there's two possible answers when you find the square root of 64. That means m is equal to negative 4 plus or minus 8. Just subtract 4 from both sides. So m is equal to minus 4 plus 8, which is going to be, and m is equal to negative 4 minus 8, which is negative 12. So those are the two values of m for which this line will be a tangent to the curve. So when m is equal to 4, okay, so y equals 4x would be a tangent. And when m is equal to negative 12, when y equals negative 12x, you'll also have a negative 12x. You also have a line which will be a tangent to that curve, okay? And so those are two possible lines that can be tangents to the curve of this given quadratic. So there we have the answer to part A. All right, so this is a very typical type of question, actually, this one. Okay, about finding the values of a constant like this, where it's a tangent, or there's no solution, or like they don't intersect, or they intersect in two places. All right, that's a very typical type of question. That's 6 part A. Now we're going to go on to 6 part B. It says the function f is defined for x as being an element of all real numbers by f of x equals x squared plus ax plus b. So f of x equals x squared plus ax plus b, and a and b are constants here. Okay, the solutions of the equation fx equals 0 are x equals 1 and x equals 9. So the solutions to the equation f of x equals 0 are x equals 1 and x equals 9. Find the values of a and b. Okay, so this is like where you know that the graph intersects the x-axis at two places, 1 and 9. Okay, that's 1 and that's 9. And we have to find, these missing values. So it's like working backwards from when you have solved an equation, right? So basically, I know that if I have x minus 1 times x minus 9, that's going to give me 0, because if I was to solve this equation, okay, if I was solving a quadratic equation, my solutions were x equals 1, x equals 9. Before I wrote x equals 1, x equals 9, I would have had x minus 1 equals 0 and x minus 9 equals 0. And before I would have that, I would have factorized the original expression, and I would have x minus 1 and x minus 9 multiplied by each other, and there would be no other constant on the outside because here is just 1x squared. So this is going to give us, if I expand this, before we had factorized it, it would be in expanded form, in the form like this. So you have x squared minus 9x minus 1x plus 9 equals 0. So you end up with x squared minus 10x plus 9 equals 0. Okay, so that's what you would get if you were, starting off. So our equation, therefore, f of x must be x squared minus 10x plus 9. And we can see the values of a and b. A is the coefficient of x, so a is equal to negative 10. And b is the coefficient or the constant, which is going to be plus 9. So a is negative 10 and b is 9. And that solves b part 1. Okay, find the values of a and b. All right, so that's a nice little question there. It's the opposite of solving the equation. It's from the solutions of the equation, finding out what the equation actually was. Right now, if the x squared, I know the x squared has a coefficient of 1, so I don't have to put anything here. But if I knew, for example, the coefficient of x squared was something else, like if it was an unknown, for example, a or b or c or whatever, I would have to put a letter here to represent what that coefficient is. Okay, because it's possible that before you factorized it, you divided by that common factor. So in this case, we know it's 1 here, we don't have to worry. This is going to be 1 there, that's fine. We don't have to worry about that step. But if it was that you didn't know what the coefficient of x squared was, you'd have to put some letter here to represent that coefficient of x squared in our, answer. Okay, now for part 2, it says the coordinates of the vertex of y equals f of x. So now we know that our equation is y equals x squared minus 10x plus 9. They're asking us to find the coordinates of the vertex of this graph. Now, to find the vertex of a graph, there's a number of ways, and all of them are based upon one particular thing, which is completing the square, right? So if you complete the square, that's a nice, easy way to find the vertex. So we complete the square, so we have bracket x minus, right? So you take this number x squared, you write it down without the square, and you took minus, and you write down half of the coefficient of this, which is going to be 5, and then you square that bracket. If I square that bracket, I'm going to get x squared minus 10x, and then I'm going to get plus 25, which I don't need. I don't need the plus 25, so I'm going to take away 25. Right, so this now is the same as x squared minus 10x. X squared minus 10x is the same as x minus 5 squared minus 25. If you expand this, you're going to get x squared minus 10x plus 25, then minus 25, you're left with x squared minus 10x. Okay, and there's a 9 sticking out the end, so you write that down. So when we write this in the full form, you have y equals x minus 5 squared and minus 25 plus 9. Okay, that's going to be how much? That's going to be minus 16, I think, right? Minus 25 plus 9. Okay, if you take negative 16, basically if you take minus 25 and if you added 10, you get minus 15. So add 9, you get minus 16. That's correct. So now we can write down the vertex. The vertex is given by a very simple little process. You have to find the value of x that makes this bracket 0, which is when x equals 5. And what you're left with on the outside is the y coordinate of the vertex, which is negative 16. Okay, so those are the coordinates of the vertex. So it's always the value of x that makes this bracket become 0. That will be the x value of your vertex. Why? Because this bracket will always be something more than 0. Okay, it will always be more than 0 because wherever you go in here, you have to square it. So even if it was negative, it's going to become positive as an output. So you'll always have negative 16 plus something. And that thing is always going to be something positive, right? So even if you put a negative value of x in here, like x equals minus 100, you square minus 105, you're going to get a positive value. So you end up with something greater than 0. So the vertex is 5, negative 16. Negative 16 is the lowest that this can ever go, and that's when this bracket becomes 0, when x equals 5. So there we have the answer to that question. All right, so that's how we deal with that question. And I think that's it for this question. It's all about quadratics, this question here. So other questions from this particular paper, the May, June 2016, when I get to answer them, will be in the playlist that will appear at the top right of the screen at the end of this video. Other questions from this worksheet, end of topic worksheet number 2 on quadratics from my collection from Cambridge worksheets. You can find them. You can find the playlist for those questions in this playlist over here. And the link here takes you to the quadratics playlist that I have answered from just general questions on quadratics from P1. And on the top here, you can subscribe to my channel. Thank you for watching and see you soon.